Welcome to my channel again. It's a series of videos explaining experiments. In this experiment, I will try to explain the gas properties, ideal gas properties. Firstly, we need to define what ideal gas is. Ideal gas is gas that idealized. The molecules don't have any volume. Molecules don't have volume. Indeed, it has volume, but in this situation, in our situation, there is no volume. Also, there is no attractive and repulsive forces between them. Also, there is only kinetic energy. Average kinetic energy, not potential energy. But indeed, it has potential energy now, but we will neglect it. So here is a given space, kind of box. Pressure 0 atmosphere Kelvin, not given, because of there is a vacuum. We will pump in air molecules here, air molecules. As you can see, the pressure increases over time as we pump in more air molecules, and we can see that there is a fixed temperature, 300 Kelvin. What will happen if we cool down this system? So there is a under ices here, cube of ices. You can observe that temperature drops quickly, and the motion of molecules gets slower. So it gets slower. And the closer to 0 Kelvin, it gets so complex to cool down to 0 Kelvin. That's why we cannot cool down below 0 Kelvin. 1 Kelvin, and finally we have here 0 Kelvin. No, what is 0 Kelvin? As you can see, there is a 0.1 atmosphere. There's less pressure. The less temperature, the less pressure in our situation. But if we heat this system, the system acquire motion. Our air molecules acquire more motion. And our temperature increases, pressure also increases, as you can see here. And it's our system in isochoric process, which means volume constant. Our volume doesn't change, but over time doesn't change. This one, they get motion. This, you can see the number of particles, 848. Let's hold not volume in constant. Let's hold the temperature constant. This one. What will be? We pump more air inside. The temperature doesn't change, so we cannot heat up or cool down. Two things that we can change. We can change our volume and pressure. Our volume and the pressure. So let's expand this. As we expand the volume, the pressure drops. As we stretch it, the pressure increases. So they are inversely proportional. If pressure increases, volume decreases. If volume increases, the pressure drops. It's called inversely proportional. So let's hold the pressure constant. Maybe pressure will be constant. What can we do? We can send out these molecules. We can see, but pressure still, volume would be too small. There is a kind of error. It's not problem. We need to understand the main concept of this gas properties. Here we have volumes of molecules, but in this our situation, in this simulation, it doesn't count. This doesn't count. We have here collision counter. It means how many. Let's restart our experiment. Let's pump air inside. And heat, a little bit heat. As we heat, the pressure increases, and finally what will happen? It explodes because of it has own minimal pressure it can hold. Okay, return lid here. Let's with here is stopwatch, here collision counter. Let's count collision counter. How many collisions occur during 10 picosecond? Yeah? To 229 collisions occur per second, per picosecond. It's too high. So the third pressure comes from how many molecules collide to the wall. Yeah? The more molecules collide to the wall, the greater pressure will be. So I explained the main concepts of ideal gas. Ideal gas. As you can see, ideal gas only there is a high pressure, high temperature but low pressure always. But in real gas there is a higher pressure but lower temperature in real gas. So keep it in mind. So thanks for watching. See ya.